Hello, today's lesson is on factoring using the greatest common factor. So real quick before we start on the actual lesson, I wanted to remind you what a greatest common factor is. So a lot of times you will see it referred to as GCF, but you did greatest common factor even as early as like elementary school. So in elementary school, your teacher may have given you the numbers 36 and 48 and told you to find the greatest common factor. So one of the ways you can do that is to write down all of your factors of each of these numbers and figure out what the largest number is that they have in common. So we know 1 times 36 is 36, 2 times 18 is 36, 3 times 12 is 36, 4 times 9 is 36, and 6 times 6 is 36. And then I'm going to do the same thing for 48. So 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. So those are all of my factors of my numbers. So then I go through and I find the largest one that goes into both of them. So it would be 12. 12 is the largest number that goes into both 36 and 48 evenly. So I would say that my greatest common factor is 12. All right, so I just want to remind you how to do it with numbers before we put letters in it as well. So let's do this. So for a warm-up, we are going to simplify the following polynomials. So remember, when you have two factors being multiplied in algebra, we do distribution, or we multiply to simplify them. So on this first one, a times 3a would make 3a squared. A times 7 would make plus a 7a. And then you have to ask yourself, could I combine those together? And the answer is no, because they're not like terms. All right, let's do the next one. So we have negative 2m times m squared. So m times m squared would make a negative 2m cubed. Negative 2m times 6m, well, negative 2 times 6 is negative 12, and m times m is m squared. Then we have negative 2m times negative 1 would make a positive 2m, and that would be your answer. All right, for this last warm-up problem, we're going to do 4x cubed y times x squared. So I can really only multiply that x cubed times x squared. But remember, when you multiply with exponents, you really add them together. So this is like doing 4 times 1, which is 4. Then x cubed times x squared makes x to the 5th. And then we still have this y that we have to multiply in. It just doesn't get multiplied with anything. Then I'm going to do 4 times negative 2 is negative 8. On this one, I don't have an x there, so this is just going to stay x cubed, but now my y times this y is y squared, and that would be your answer. So what is factoring then? So factoring is separating a polynomial back into the product. So what I mean by that is this. If we have something like this is a polynomial. When we factor, we're going to make it look back like that, like those two things being multiplied. Or like the second example, it's taking this polynomial and splitting it into those two factors. So it's separating a polynomial back into a product. So separating a polynomial back into a product. So for instance, simplest form could be 4a squared plus 8a, whereas factored form will look like two things being multiplied, 4a times a plus 2. So you can always check, if I were to distribute that in, I should get what I started with. 4a times a is 4a squared. 4a times 2 is 8a. So polynomials that cannot be factored are called prime. They cannot be factored. All right, so there are several factoring methods. what approach you use depends on what polynomial you're given. So the first factoring technique that we are going to start with is the greatest common factor. So you will follow the following steps. So first identify the greatest common factor of the polynomial, kind of like I did in that little example to start. So first check the coefficients. Remember, that's the numbers out front. So the numbers in front of the variables. Oops, I'm not going to fit that there. Then look at the variables. A variable must be present in all the terms to be a greatest common factor. So what that means is in all the terms, it would have to have an X or it'd have to have a Y. It doesn't have to have the same number, but it at least has to have that variable. If a variable is present in all terms, take the one with the smallest exponent value. All right, and then we divide each term by the GCF and leave the remaining factors in parentheses, and then we can always check our work by distributing. So it says factor each polynomial, check your work by distributing. If a polynomial cannot be factored, write prime. All right, so we first check our coefficients. So between 3 and 12, we have to think about what goes into both of those numbers evenly, kind of like how I started. So I know that 3 is 3 times 1, and that's it. But I also know that 3 times 4 is 12. So that means that 3 is our greatest common factor. Then you want to check the letters. This one has an X, but this term here does not. So they do not have an X in common. So now we would write what's remaining. So I factored out that 3, and 3 divided by 3 is 1. So I have 1 and that X. And then 12 divided by 3 is 4. So we would be left with X plus 4 in parentheses. Of course, you do not have to write that one. You could write 3 times X plus 4. And then we can always check by distributing back in. We should get what we started with. So 3 times X is 3X, and 3 times 4 is 12. Is this what I started with? Yeah. So that means I put it in factored form correctly. All right, let's try go ahead and try number 2 on your own. All right, so on number 3, it says 8m plus 36n. So we're gonna have to think of what divides into 8 and 36 evenly. So we know that 8 can be 2 times 4 or 1 times 8. 36 could be 1 times 36, 2 times 18, 3 times 12, 4 times 9, or 6 times 6. So we're looking for the greatest common factor that goes into both of those. So it's going to be 4. So we can take out our greatest common factor of 4, and we have to write what's remaining. So when we divide 4 out, we're left with a 2. We still have that m there, and then 36 divided by 4 makes a plus 9m. So our answer would be 4 times 2m plus 9n. All right, go ahead and try number 4 on your own. All right, let's go ahead and do number 6 together. So we have 4y squared minus 24y. So we're going to think, what are 2 numbers that go into 4? So 1 times 4 or 2 times 2. We'll do the same thing with 24. So we could have 1 times 24, 2 times 12, 3 times 8 is 24, and 4 times 6 is 24. So we're looking for the greatest common factor between these two, and it's going to be 4. Also notice in this one, we have a y squared and a y. So we have a y in both terms. The first one has 2 y's, and the second one has 1 y. So they have 1 y in common. It's always the lowest number of that variable. I can't say they have 2 y's because they both don't have 2 y's. Only one of them has 2 y's, but they both have at least 1 y. So when we go to divide out our greatest common factor, which was 4, 4 divided by 4 makes 1. We had 2 y's here, but we're going to factor the 1y out because that was in common. Our GCF is 4y. So I have 4y, comma, I have 1y left, minus, then 24 divided by 4 makes 6. I had a y here, but I factored it out front. And remember, we can always check to make sure we got what we started with. So 4y times 1y would make 4y squared, and 4y times negative 6 would make negative 24y. So I know I did that correct. All right, let's go ahead and try number 8 together as well. So on number 8, 14 could be 1 times 14 or 2 times 7. 18 could be 1 times 18 or 2 times 9 or 3 times 6. So the largest number that goes into both of them is actually only a 2. Then this one has a G and an H, and this one just has an H. So they both have an H in common. So my GCF would be a 2 and an H. So then I write what's left. So 14 divided by that 2 is 7. I had a G and an H, but I factored that H out front, so I'm just left with a G, minus, and then 18 divided by 2 is 9. There was an H here, but I factored it out front. So that is just my answer. So then we can check it by multiplying the 2H back in. So 2 times 7 would make 14, and then H times G is just GH, and then 2 times 9 is 18, and then my H. And that's exactly what I started with. So that would be my answer. All right, go ahead and try number 10 on your own. All right, next I'm going to do number 16 with you. So it's the same thing, even though there is 3 terms in this one, same thing's going to happen. So let's write out our factors for 9. We could do 1 times 9 or 3 times 3. For 18, I could do 1 times 18, 2 times 9, or 3 times 6. And for 24, I could have 1 times 24, 2 times 12, or 3 times 8, or 4 times 6. So we have to find the number that goes into all 3 of those, so it would be 3. So 3 went into all of them. Then we have 8 R's in my first term and no S's. We have 2 R's and 1 S, and 1 R and 2 S's. So we have 8 R's here. We have 2 R's and 2 S's. We have 1 R and 2 S's. Or no, I said that backwards on this one. We have 2 R's and 1 S here. Okay, so to figure out what's in common, well, they all 3 don't have an S. So we can't say there's a greatest common factor of an S, but they all have at least 1 R. So they have 1 R in common. So my greatest common factor is 3R. So then we write what's left. So 9 divided by 3R is 3R to the 7th. So another way to think about this, you could count, and there would be 7 R's left over. Or think about when we divide it with exponents. 9 divided by 3 is 3. And then remember with the exponents, we subtract them. 8 R's here minus my 1 R means I'd have 7. Then I'll do the same thing here. Divide by my greatest common factor. 18 divided by 3 is 6. 2 R's minus my 1 R leaves me with 1 R. I didn't do anything with my S, so I have that. Then 24RS squared divided by 3R. 24 divided by 3 is 8. R divided by R cancels, so I'd have 8S squared as my answer. Then again, we can always check by distributing to make sure we did this correctly. So 3R to the 1st times 3R to the 7th would make 9R to the 8th, because we add exponents when we multiply them together. Then 3R times negative 6RS would make negative 18R to the 2nd. Again, we add those exponent S. And 3R times negative 8 would make negative 28R S to the 2nd. And that is exactly what we started with. So that is correct. All right, I would like you to try number 18 on your own now. So first list out all of your factors between 12, 36, and 6. Keep in mind you have 5 A's and 2 B's, 4 A's and 3 B's, and 2 A's and 2 B's when you think about how many they have in common. All right, I'm gonna do number 20 with you. Let's do 20 next. So if I write down all my factors of 18, I'd have 1 times 18, 2 times 9, and 3 times 6. For 24, 1 times 24, 2 times 12, 3 times 8, and 4 times 6. For 36, 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So if we look at our greatest common factor, 6 goes into all of them. So I know I'm factoring out a 6. Then if we look at our letters, let's see here. We have 2 X's, 1 Y, and 1 Z. We have 1 X and 2 Z's, and we have 1 Y and 3 Z's. So all 3 of them do not have an X. All 3 of them do not have a Y, but all 3 of them do have at least 1 Z. So my greatest common factor would be 6Z. So that means I'm going to divide all of these by 6Z. So if we write what's left after we factor that out. So 18 divided by 6 is 3. I still have an X squared Y, but the Z divided by Z will cancel, minus 24 divided by 6 is 4. I'm going to write it down here. I still have that X, nothing to cancel with, but the Z to the second divided by that Z to the first will just make a Z to the first, plus 36 divided by 6 is 6. I have that Y, but I had 3 Z's divided by 1. Subtract your exponent and you get Z squared. So that would be your answer. All right, go ahead and try number 22 on your own. All right, that concludes your video on factoring out the greatest common factor.